Hello, I'm Carol Wontrout with Cole Morgan, and this is 2 Minutes of Motion. This is video number 2 in the Getting Started with KAS programming series. This video focuses on the dictionary and data types in the IDE. To manage data in group formats, arrays and structures are supported. In the dictionary, 1, 2, and 3-dimensional arrays can be set up. For demonstration, a 2-dimensional array will be created. Next, we will run the project on the KAS simulator. By double-clicking on the array variable, the present values can be monitored or changed. Structures can also be created in the dictionary. As an example, a structure will be created with 4 elements to define the input motion parameters of a jogging function block. Right-click in the dictionary and select Add Structure. A new structure is automatically created with the generic name New Structure. It can be renamed to better show its purpose by right-clicking on it and selecting Rename Structure. Right-click on it again to specify the elements. The first one will be velocity. To add the others, another dictionary feature, Edit Variables as Text, will be used. It opens up a text editor and allows fast entry. When finished, save and close. Here we see that the elements were all added. Edit Variable as Text is also available for other items in the dictionary, such as global and local variables. Structures must be instantiated for use in the project. Instantiating a structure allows the program to execute multiple instances at the same time. As an example, an instance of motion parameters will be created to define the input to the MC velocity function block in the main program. Right-click on the main program in the dictionary, click on Add Variable, find the structure type that was just created, and assign it a unique name typically relevant to its usage. We can go to the main program and use the structure to set up several of the MC velocity function block inputs. Next, we will take the structure's acceleration element and use it as the acceleration input to the MC gear in function block. Next, we will use the deceleration element of the structure and use it as the deceleration input to the MC gear in function block. And finally, we will use the structure's jerk element and use that as the input to the jerk input of the MC gear in function block. Variables are also used to create instances of general PLC functions, such as a timer. An example is ton, or motion, such as an incremental move, MC move relative function block. Variables are also used to create instances of subprograms, or UDFBs, user-defined function blocks, located in the subprogram section of the project tree. Going back to the gearIn2 function block, gearIn2 is a variable that has been defined in the dictionary to be an instance of the KAS standard function block MC gearIn. Variables are also used to define instances of built-in library functions. These functions are typically used as an input to PLC open motion function blocks. The list of these functions is as follows. Variables are also used to define instances of two specific structure formats named enums and bitfields. Enum and bitfield variables each have its own tab in the dictionary. An enum, or enumerated type, allows you to define a data type and define a specific set of accepted terms relevant to the application. Here are examples from the help file. The first one defines a variable season with acceptable values of winter, spring, summer, and fall. Bitfields allow packing multiple pieces of data together in one variable, with each bit having no dependency to another bit. Bitfields are used to define custom variable types and values. Here we have defined a bit called axis state with 4 values. The last variable type to discuss is variables used to define data automatically created by the compiler when compiling the project. These are based on what the user has defined in the IDE in the following areas: PLC open code is a UDFB containing information on the PLC Open motion axis in the project. EtherCAT code is a variable structure of the EtherCAT nodes in the project. Profiles code is a UDFB containing information on the CAM profiles in the project. In the project templates, an instance of these is called when the project starts